Hello, guys. My name is Desmond, and I welcome you to my lesson for today, where we'll be looking at your mathematics, obviously part of paper 1. So, ladies and gentlemen, please do allow me to say, Denzel. It is very much important that I say it is very, very much important to see you because what I'm about to say, it's massively. Hey, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, no kutula. Please, Larissa, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. Okay, as you can see, we will be looking at number patterns, which is a new chapter that we'll be starting with in today's lesson. Okay, what I'm going to do is to quickly take you through an introduction, of which, if we still have some time towards the end of this lesson, we will go through that math problem that was sent in the group. I'm hoping to cover everything in today's lesson, but most importantly, in case if you've got a question, please do make sure that you do not allow me to continue without you fully understanding. So remember, the notes that I'm going to be using to present today's lesson are posted in the library. So just in case if you are not in the library, make sure to indicate so that I'll give you a link to our online library so that you can access all the notes that we use. Okay, so number Ian, we are looking at a number pattern, which is what I'm going to explain. Secondly, we'll look at what we call sequences. Thirdly, series. And lastly, we will go through the question that was posted in the group. So, guys, just a last confirmation. Are you guys happy on your side? Is everything clear? For those who haven't spoken, just unmute your mic and say something, just so that I'm aware that you guys are able to use your mic and control it very well.
Sir.
Yes, sir.
Ako Zazaza, can you guys just say hello or just anything so that I know you guys are able to control your mic?
Hello. Hello.
Okay.
Hello.
That confirms all. It's in order from everyone's side. So number one, I'm going to explain what is meant by number pattern. I'm hoping that I will make sure to take my time and slowly make sure that I get straight to the point. Okay, a number pattern. What exactly is a number pattern? Some of this information I might not need to write it down because all the info, it is posted in the group. If you like, you can still open those notes posted in the group. But now, number pattern. What exactly is a number pattern? Bantu bakiti. Number pattern, it simply refers to a list of numbers in order. That's it. List of numbers in order. This is what we call a number pattern. That's it. So every time when someone says number pattern, just know that we're talking about a list of numbers which are in order. Very, very much important, ladies and gentlemen. Okay, again, what you need to be aware of under number pattern is that at least, remember, when we say at least, we are saying starting from that. So in this case, we are saying at least 3 numbers needed to work out if number pattern, numbers form a pattern. So what we are saying is at least 3 numbers. This is what I want to emphasize. At least 3 numbers are needed in order to work out if those numbers form a pattern. So that means we can't tell if a pattern forms from just 1 number. Also, from just 2 numbers, we cannot tell if this list of numbers form a pattern, but we can only tell starting from 3 numbers. Then we notice that this is 1, 2, 3. Then we can predict the other numbers that comes after these 3 numbers. So very, very much important that this chapter we are mostly interested in knowing 3 numbers. Otherwise, if for 3, they are going to specify to say, yes, it forms a pattern, and this is the type of the pattern. You will see as we work out some problems. So the other thing that you need to be aware of, obviously, it means anything less than 3 numbers, we cannot work out if those numbers form a pattern. Maybe let me give you guys an example so that you have an idea of what I'm talking about. Let's say, for example, you have 2 and 4. Good people, different number patterns are possible if you only have just 2 numbers. What do I mean by that? You can have, from that, you can derive this number pattern, 2, 4, 6, and so on. Again, you can also have 2, 4, 8, and whatever. And again, you can still have 4, 2, 4, 2, 4. So that's what we mean. Say it is not easy to tell if there is a pattern based on just 2 numbers. A pattern may be there, but might not be able to predict the type of a number pattern formed from just 2 numbers. So we actually need at least 3 numbers. In that way, we'll be able to tell that this is the pattern that is forming. Something that you also need to be aware of, let me note it down to say a single number in a pattern is called term. Let's say, for example, we have 2, we have 4, we have 6, and so on. Listen very carefully. A single number in a pattern is called a term. So we have 1, 2, 3 called a number pattern. So when we talk about a single number, we talk about that. Can you see? This is a single number separated by that sign. This is a single number. As long as it's separated by that sign, it is a single number. It doesn't matter whether it's negative. It doesn't matter whether it has some letters. For example, 2 minus x separated by that, 2 minus 4, x separated. As long as it's separated by that, we call it a single term. Single term, a single term, as long as it is separated by that. So a single number in a pattern is called a term. Maybe because mathematically we do not like writing words, we always try by all means to summarize those words. Let's maybe refer to this as T1. Obviously, T term. So that means that single first number will be referred to as term number 1, this term number 2, This will be term number 3, and then you can still have some more terms. Most importantly, guys, the number of term shows its position in the sequence. What do I mean by that? In short, I'm just saying if you have something in a T10, what it means is that here we're talking about term number 10. In other words, it is actually the 10th term in the sequence. So maybe let me use that to explain. This is T3. It refers to term number 3 in that sequence. Otherwise, you can say this is the third term being referred to as T3. But now, what if we want to generalize? By generalizing, what if we want to know about the future term? Now let's maybe refer to it as a future term. So it's more like how do we represent maybe term 30? Obviously, you'll say term 30. What about term 60? It will be term 60. What about term 1000? It will be term 1000. But because you cannot write 2 4s and continue up until you get to 1000, for you to end with just 3 terms is enough. But you can have a general representation to get to a term number 1000. So that's why just say maybe the future term, let's just refer to it as the nth term. So the nth term could be any number in that sequence. Most importantly, guys, normally when I start with new lessons, I'm not really expecting you to grab everything from say. I do understand very well that over time, that's when everything is going to make sense. But for now, just make sure that you listen very carefully, you listen attentively, and just make sure that whatever that is being explained, you are able to hear all of that. Before I go deep, are we still together, guys? Are you sure I wasn't breaking? And again, you can clearly be able to see where I'm writing there. Just a confirmation before I continue.
Sir, suggestion, please.
Yes, Umi.
First, you're breaking a bit, but not much.
Yeah.
You're going off and on. And the second thing, please, can you change your pen? Your pen is a bit faded. I cannot see.
Yeah, I've also noticed. I tried to look for another one. I'll just quickly
use the blue one. Is better than black.
The blue one is better. Okay, let
Sure,
me quickly check that. Okay, you are right. The blue one is better. So, anyone to confirm if we are all on the same page on your side?
Yes, sir.
Last one to confirm.
Yes, sir.
Okay. So I'm just going to remove all of this. That's all that I wanted you guys to be aware of regarding number patterns or under number patterns. That's all that you needed to be aware of. So now let's quickly talk about sequences. We'll see what's under sequences. Most importantly, these notes they are available in the library. So just make sure that you are in that group and you are able to access these notes. Most importantly, the lesson is being recorded, it's going to be posted, and you can easily catch up in the future. So Now, what I want to discuss under sequences is that we've got 3 types of sequences that we'll be looking at. 3 types of sequences. Number 1, maybe let's talk about what we call an arithmetic sequence. Arithmetic sequence. The other type of a sequence that we'll be talking about, maybe let's focus on what is it? Geometric sequence. Geometric sequence. And lastly, a quadratic sequence. I'm telling you guys, this chapter is very, very, very easy. All that you need to know is these 3 types of sequences and also understand their characteristics. For now, it might not make a perfect sense, and most importantly, you might not be able to derive any possible questions. But as we start solving for some problems, that's when you will derive some questions. So do not worry that much in case if you feel like you understood everything without having any question, or if you feel like you are completely lost or you are not able to connect the dots. I've also went through the same thing where when I study using a textbook, it doesn't instantly make sense, but the moment I start answering exam type of questions, that's when I'm able to make sense of some of the information that I've read in the textbook. Okay, so now let's quickly talk about the first type of a sequence. But wait, what is a sequence? Or maybe let's say, what are we referring to when we talk about an arithmetic sequence? This one. So we are talking about a sequence where the common difference between consecutive terms is constant. A sequence where the common difference, remember the word difference, the moment we talk about the difference, mathematically, you should think about the sign a minus. When we talk about the sum, remember it's a plus. And then when we talk about what the product, multiplication, and then that other one of a, what is it? Is it quotient, which is a division. So mathematically, every time when you share the difference, just remember a 2 minus in each other. In the definition, we say a sequence where the difference, remember the word common, mathematically referring to the same. Where common difference between consecutive terms is constant. For example, if we have 2 for a, let me keep it simple and say 2, 3, 4, and whatever. When we talk about common difference between 2 consecutive, the word consecutive, that means between that and that, not between this and that. That is why in the definition they had to say between consecutive terms. This is the term, this is the term, term 1, term 2. So the difference between these 2 consecutive terms has to be constant, meaning it has to be the same. So that means when you say this minus that, which is 3 minus 2, it has to give you 1. Okay, force is also when you say this minus that, it has to be the same as that. Then in that way, where you have common or the same difference, you are therefore having this type of a sequence. So this is the first type of a sequence that you need to be aware of, and it has a formula. So let's quickly write down that formula and see how it looks like. Maybe let me remove that and the formula says, let me remember the honorable member's suggestion, make sure that I use that. So that means Tn. What is T? Remember, Tn refers to the nth term. This is that general term, which means n could be referring to term number 1, term number 2, term number 3, or number whatever in the sequence. So Tn is equal to A plus into n minus 1 multiplied by D. Maybe let me try to explain each of those so that when we continue, we are on the same page. This refers to the nth term, just like I've explained. It could be term 1, term 2, term 3, term 4. Any term in the sequence is referred to by Tn. So A, Bantu Bakit, it refers to the first term. What is the first term? In short, I think it would make sense if I say T1. T1, it is that first term followed by second term, followed by third term, and whatever. So this first term, it is always T1. It is called a term. It is called A. Remember from the alphabets, letter A, it is the first letter. So that's how you can remember that. In this case, we're talking about the terms. Then 8 refers to term number 1. N, it just refers to the number. You will understand it better as we continue. For example, we can have 2, 4, 6, and whatever. I think it might make sense if you say the number for term number 2 is 4. So you see, term number 2 has its number being 4 in this case. Otherwise, maybe if we have 1, 2, 3, 4, 5, let me just try to be realistic and say, let's say 4, 1 over 2, 1 over 7. I'm just giving an example, guys. 1 over 5. So n, it refers to the value in the sequence. For example, term number 4 is actually equal to, let's see, 1, 2, 3, 4. So it's equals to 1 over 5. So 1 over 5 is actually the n of that sequence in the number. You can understand that. I'm telling you, you won't have any confusions regarding answering questions, because sometimes what confuses you guys is not knowing whether they want you to calculate n or they want you to calculate n. Even myself, from time to time, it does confuse me. But one thing for sure, since we are together, we will find a possible way in order not to forget it and to never confuse it.
Sorry, I have a question.
Yes, I was asking a question there. Remember to unmute your mic, honorable member.
So, in a question, would you put, like, let's say it's T4, would you put 4 or would you put like the 1 over 7, I think?
I'm just not sure of how to respond to that. But one thing for sure, I think it will be useful. Sometimes if a question is not clear, even the response is likely not clear. But let's say, for example, in case if we get to that question, just remind me that you're referring to that question. But if, for example, they asked regarding term number 4, you are therefore going to say term number 4 is equals to 1 over 5. I'm just trying to say something in response to your question, even though I'm not confident that I fully answered your question. But one thing for sure,
in terms of n, you know, n, the number n, it says
yes, and the number.
Yeah, there. Would you put 4 or would you put 1 over 5 is what I'm asking.
Oh, okay. I see. But now I will need a full. I think I get what you're saying. That's if you are calculating what? I'm just not if I fully understand the question there, unless if I'm confusing that n with the tn. But otherwise, let's say if the question says calculate T4, this is where you put 4. Yes, this is where you put a 4 Vuyiswa, because you're going to say term number 4 equals to. That means already there you've put in 4. Whenever you see n, going to put in a 4. Then when you calculate a term number 4, it is going to give you 1. Is it 1 over a 5? So that you will end up having a final answer look similar to that, where you say term number 4 is equals to 1 over a 5. I'm not sure if at your question there, voice.
Yes, that's what I was asking.
Okay, but for now, let me say everything is going to make perfect sense when we solve exam questions. One thing for sure, Vuyiswa, even now, sometimes I do get confused between the TN and N, especially when it comes to having to discuss it. But when a question comes, you will realize that you can actually have a standard strategy of approaching those type of questions. Okay, quickly, D, obviously, it refers to that common difference. So that's what it refers to. So maybe let me say this number, it is that number that you use to calculate whatever the nth term that they want you to calculate. Maybe leave it there, and then as we continue, we will notice in the question in terms of how it comes and how we substitute. So now, regarding the formula, that's all that I wanted you guys to be aware of. I'm just not sure if there's any question before we move on to the next type of a sequence. Do you guys allow me to continue?
Question?
Yes.
Sir, can I ask a question? Can you refer to n as the position of the term?
Can you refer to n as the position of the term? Yes. I think you've put it nicely and straight to the point there. Because she's saying, can we refer to n as the position of the term? Because when we say 4, when we say number 4, we are referring to term number 1, 2, 3, 4 being the position of that. I think honorable member, in a form of a question, has actually made it clear and even better than I try to explain, because I think now I'm also confident when I say n refers to the position of the term in a sequence. Is that your understanding, Larissa?
Yes, sir. Thank you.
Yes, okay. So now I think we can now move on to a geometric sequence. So I'm just going to quickly remove all of that, and we'll quickly discuss a geometric sequence. Okay, here that's when there is a common ratio. Let me maybe write down a common ratio. Remember, common, the synonym could be same in maths. And then the ratio, when we talk about the ratio, we talk about something over something. Doesn't matter whether it's physics or any other subject. The ratio refers to something over something. So under a geometric sequence, that's where there is a common ratio between consecutive terms. If there's a common ratio between consecutive terms, that's when we can say we are dealing with a geometric sequence. You obviously have a formula also in this case, which says Tn is equals to A to the exponent, AR to the exponent n minus 1. So obviously that it still refers to the nth term. So that refers to the nth term. And then still that it refers to the first term being T1. And then that R, it is that one of the common ratio, where we get it by saying something divided by something. And then N, it is the number. Best explained in a form of question where Larissa said, can we regard n as referring to the position of the term? So maybe let's try to generalize a formula for calculating R. So we just said R is actually the ratio between two consecutive, not necessarily two, but between consecutive terms. So if, for example, we are having a sequence being 2, maybe let's say 4, and then maybe let's say 8, then whatever. So that means it has to be this term being term number 2. Because it's a ratio, it has to be divided by the previous term being term number 1. If it is the same value when we say that term being term number 3 over term number 2, if it is the same value, then we know that we are dealing with a geometric sequence. So that means for us to know if we are dealing with arithmetic, the difference, it is the key. Under geometric, then R being the ratio, it is the key. Most importantly, this is referred to as the first difference. What do I mean by the first difference? Before I forget, if you are having 2, 4, 6, when you say this minus that and it gives you 2, and you say this minus that, it gives you 2. Can you see? This is the first row of you calculating the difference. So that 2 refer to it as the first difference. You can further continue to calculate the difference and say that minus that, and it gives you the 0. So this is what we refer to as the second difference. If you continue, it's referred to as the third difference. But for us in high school, we end there on the second difference. So just remember that arithmetic, first difference. You will therefore notice that what I've just explained, it actually brings us to the third type of a sequence, being a quadratic sequence. So what I've explained is all that you need to be aware of regarding a geometric sequence. I'm just not sure if there's anyone who's got a question before I move on to that type.
No, sir.
No question. Okay, so now I'm just going to quickly remove all of that, and then from there, I'm going to quickly explain all that you need to be aware of regarding a quadratic sequence. Under quadratic sequence, most importantly, we say at least a 4 numbers are needed to determine whether the sequence is quadratic or not. And you will notice why. And the reason to that is because under a quadratic sequence, we confirm it by getting the common second difference. The common second difference. Whereas with arithmetic, we get it after finding the first common difference. Maybe let me give you guys a very quick example. So let's say we are having 6, we are having 12, we are having 22, we are having 36, we are having 54. Let me see, 1, 2, 3, 4. I think it's too much. Let me remove that and see if we can still achieve our goal of determining whether this is a quadratic sequence or not. Remember, for us to know whether it's a quadratic sequence or not, we only need at least 4 numbers. More than 4 numbers, it's a bonus. So how do we determine if a sequence is a geometric or not? So you are still going to do the same. You say that minus that. What are you getting there? That is 6. What is 22 minus that? I think that is 10. Is it 10? And then what is 36 minus that? Is it 14? I think that is 14. What do we call that? Which is what we have just done. It is called the first common difference. I used to call it the first CD. CD for common difference. So because the first common difference, or because the first difference, it is not common, I will remove that C and just call it the first difference. Why the first difference and not the first CD? It's because that first difference is not common. Then let's see. You are therefore going to say that minus that. What is that? That is 2. That minus that. What is that? That is 2. So can you guys see that on the second difference, it is actually common? So that is why I'm going to call that the second common difference, which is a confirmation that this series, not series, but this sequence, it is actually a quadratic sequence. So that means under that, you need to get to the second common difference in order no. You
Isn't it
How
four?
did the 6 make 2?
can you again, honorable member, what did you say there?
You made an error.
I made a
It's 4.
mistake.
Yeah, the second
Oh yes,
common difference.
yes. Not 2, but 4. So most importantly, the second difference, it is common. For as long as it is common, it confirms that we're dealing with a quadratic sequence. So What I'm about to explain now, it is the general formula associated to a quadratic sequence. So I'm pretty much sure that this part made sense. So this is the general formula, Tn. It is equals to an squared plus bn plus c. Guys, the word quadratic, it should always remind you of a quadratic equation or a quadratic formula or whatever that you have learned since we started regarding or related to quadratic. When you solve the process, it is the same. That is why I had to emphasize those calculations. And you'll be writing a test on Saturday based on those. So now let's try to actually explore what you need to know regarding that general formula. So they say term number one of a quadratic sequence, it is actually the same or equals to A being that A, plus B being that B, plus C being that C on the formula. Just remember that. Don't worry about it making sense or not. Secondly, they say the first value of the difference. The first value of the first difference is equals to 3a plus b. Maybe for this to make sense, let me quickly rewrite that. We had 6, we had 12, we had 22, whatever. No, we needed 4. So let's say 36 there. So what did we do? We said that minus that, that minus, what was that? This, we got 6, that, what did we get? We get 10, that, we got 14. And we said that minus that minus that, we got 4. So what I'm talking about here, Bantu Bakiti, is that T1, what is T1 there on that sequence? T1 is term number 1. This is term number 1. So it's more like term number 1, it is equals to the whole of that. So on that sequence, it's more like I'm saying A plus B plus C, it is actually equals to 6. That's what I'm saying. When I say the first value of the first difference is equals to 3A plus B, what is the first value of the first difference of that? Is there someone who wants to guess? What is that value?
6.
Yes, it is 6. That 6. This value, it is the first number of the first difference. So it's more like we're saying this is equals to 6. So don't confuse this 6 with that 6. This 6 is for that, and this 6 is for that. And then lastly, they say the second CD. This first value of the second CD being a common difference, it is actually equals to 2A. So it's the same as I'm saying 2A is equals to 4 for that sequence. Guys, you won't believe if I say that's all that you need to be aware of under quadratic sequence. I'm not sure if there's someone who's got a question before we start answering the question paper that was sent in the group. But quickly, I'm just going to make you aware of what is meant by a series, which is what we will not cover in this lesson, but it will only be covered in specifically grade 12, I think. So that means in that grade 12 group, that's where we are going to do a lesson on a series. So it's going to be a special lesson specifically for grade 12s. But for now, anyone who's got a question in relation to what we've just done there?
Can
No,
you
sir.
repeat? Say, can you repeat T1 is equal to A plus B plus C is equal to C?
Okay. Let me quickly try to explain that one. Let's say, for example, we have 0. I'm just going to write something which doesn't make sense so that we don't really get to let's say 1 over that, 1 over that, 1 over that, 1 over that. So if you want to determine if this is a quadratic sequence, you're going to say this minus that. Let's say, for example, you get a 1 over a 2. I'm just giving you an example. That's why I said I won't do something that makes sense. Let's say that gives you that, and then this gives you that. And then you also say this minus that. Let's say it gives you 1. And then this minus that, it gives you 1. So there's a formula under quadratic sequence which says this first value can be equated to A plus B plus C. So that means on this sequence, A plus B plus C is equals to 1 over 2. And then this one, the formula says it's actually equals to what is it? Is 3A, let me just quickly check, is 3A plus B. It is actually equals to that being 1 over 2. It doesn't mean always these values are going to be the same. Sometimes they'll be different, sometimes they'll be the same. And again, there's a formula for that which says 2A, it is equals to that being 1A in this case. So if you can have this value, that value, and that value, you can answer any question related to a quadratic sequence. But you will realize that for you to have this value and that value, you need at least 1, 2, 3, 4 values so that you can say this minus that, that minus that, that minus that. And then you say this minus that, that minus that. That's how you get 1, 2, 3, which has these formulas. Then whatever that you'll be doing is just for you to use this to simultaneously solve for the A value, B value, and C value. That's where you apply your understanding of simultaneous equation or of solving problems simultaneously. But this one is easier than a simultaneous equation. I'm not sure, honorable member, if it now makes sense what I've just explained. I suppose it makes sense. I couldn't hear you, honorable member. Maybe you forgot to unmute your mic, but I'll just make an assumption that all is clear. Okay, so quickly, I want to make you guys aware of something. Under series, I've always been using the way sequence, or number pattern. The moment you start using the word series, you are talking about a completely something new or different from what we have done there, but also not complicated. We only have two types of series that we'll be looking at, being an arithmetic series and a geometric series. Only two, which means we do not have a quadratic series. How do you a series? So I'm just going to quickly explain the difference between a sequence and a series. A sequence is written as, obviously we have a term, let's say term 1, it has this sign, and then you have term 2, it has sign, you have term 3, and you have that. But when it comes to a series, we see when we add terms of a sequence together, we form a series. Meaning, when we add, you see the and sign there, when we add terms of a, a sequence, we form a series. So, in short, the difference between series and sequence is that under sequence, you are having these things. I think those are the semicolons. But in series, you are having the plus signs. So that's where you will realize that under series, you apply different formulas. There's a formula for arithmetic and there's another one for geometric, which is something that we'll be looking at in that specific group. But for now, we'll leave it there. So I'm about to say,
Sorry, sir.
let's quickly, is the question coming through? Ayanda?
Sorry, sir. There is a problem with the screen this side. It doesn't show. Yes, sir. Hello?
Is it everyone who's not able to see?
Hello, sir.
Yes, can
No
you hear me?
network. Hello? Yeah, no, it doesn't
Guys, is
show
it
what
easy
you're
for
writing here.
Carol?
I can
Am
hear
I
you, but the
breaking?
script doesn't show what you're writing.
We need to confirm a voice. Can you hear me? And can you see there?
Breaking, sir, but the screen doesn't show what you're writing.
Yes,
It
I can
doesn't
hear
show I'm
you,
writing.
but the screen is a bit
Okay.
blurry. Yeah.
Okay, let me leave and then I'll join. How about now? I'm not sure if it's clear. Can someone maybe, Ayanda, how is it now? Can you see?
It's show plus it's play.
Is
I
it
can't
black?
see it clear.
She can't be seen.
Yes.
Let me check. Janelle, can you clearly see from your side or is blurry? Rosie, how is it on your side? Anissa?
It is a bit blurry, but because I have eyes, very sharp eyes, I can see what's written.
Let me do this. How about now? Is it still blurry? Umi, how is it now? Maybe let me do this. Guys, I need your response on this one. I'm not sure if I'm
It's
also
clear.
breaking. Zozozo, how is it now? I'm not sure if it's clear or not, guys.
See, it's
I
clear.
need your response.
It's clear. There is a problem that the screen is going and coming, but it's clear for now.
Oh, okay. No, I see. Maybe let me try to switch off that and check. How about now?
So it's worse.
Now it's worse. Okay. Maybe I need the light. And also, let me go out. I'll come back. I just need to connect using Wi-Fi. I'll leave. Okay. How about now? Is it still the same?
It's better now.
It's clear now, bright.
Okay. Just in case if it does like it did, where it goes on and off, just let me know so that I can keep on trying some different things. Okay, so I was saying maybe Zozo, I will check if there's a clear lesson that I've done last year. I'll just check if it covers everything, because what I'm explaining now, you might find that I've done the same lesson early last year. Obviously, that was before some of you guys discovered my lessons. But now that you do, even if the quality of this lesson was not that good, I'm going to make sure that I retrieve those previous lessons, because I'm explaining almost the same thing. But now, let's go back to that question that was sent in the group and see if maybe we can attempt to answer this question by applying what we have just learned. Guys, just make sure that whatever that I'm writing is correct. So they say, given the linear number pattern, given linear number pattern. So I'm not going to rewrite the questions, but I just want you guys to be aware of this. We're having 8, we're having 3, we are having -2. Okay, they're saying given linear number pattern. Okay, here comes the question. How many number patterns did we discuss in today's lesson? This is me asking you guys a question. How many
3.
number patterns? What
3.
are those?
Arithmetic, geometric, and
quadratic.
And quadratic. So now, since we have studied 3 number patterns or 3 sequences, from that statement, are we able to tell the type of a sequence that we are given?
Yes.
What type of a sequence is that?
and arithmetic.
Which means the word linear it refers to an arithmetic. So if they don't say arithmetic and they say linear, just know they are referring to the same type of a number pattern. What does it mean? It means when we say this minus that, we have to get the same value as that minus that. That means we are going to have the first common difference. So that's what I normally do before I even start looking at the questions. I check if I know the type of a sequence. If I don't, I will need to try and find out before I have a look at the questions. So what is that minus that? What are we getting there?
-5.
Okay, -5. What about this minus that? What are we getting there?
-5.
-5. So can you guys see that we've got the first common difference, which means this is indeed a linear or arithmetic. So now let's have a look at the question. So 3.1.1, it says write down the next two terms of the pattern. So some of you might be knowing how to work that out, but I'll just explain it so that someone who's got a question will be able to ask any question. So let's see. Most importantly, obviously you got those in reverse. So that means for you to get those two numbers, that's if in the forward direction, if you say this plus that, it has to give you that. That plus that, it has to give you that. Meaning, this is what you add with that same common difference, and then it is going to give you that. And that, you add it with the same common difference, it gives you that. So that means you need to add 2 with the common difference, it gives you that. You take that value, add it with the common difference being -5, and it gives you that value. So it's given 2 marks. It has to be an easy question to work it out. So what are the values of those next two terms?
Candy, -7 and -12.
-7 and -12, yes. So that means you will say -7 and -12. -7 and -12. So now moving to 3.1.2, the question says determine the nth term of the pattern. The nth term of the pattern. And we know very well that the nth term is actually Tn, and we know it has a formula being A plus into n minus 1 multiplied by d. So every time when they want you to calculate the nth term, they are actually looking for a formula in the form of n. That's it. I'm not sure if it makes sense to everyone. When they say nth term, they want you to give equation in the form of n. So let's see if we can substitute.
9 is equals to
Yebo, go for it. Okay, what is A? A is the first term. What is the first term there? The first term is 8. So we're going to have 8 plus into. This one we have to write it as n because we're calculating for the nth term. You minus 1, and then what is d? D, we just calculated it, is a -5. All you do is just to simplify. So you're having 8, remember that by that, that by that. So that means you're having -5n, this and that, it gives positive, that times that, it gives us that. Meaning we end up having, what is this plus that? I think that is 13. So it's more like we end up having our Tn being equals to 13 minus 5n. Even if maybe you got your Tn as negative 5n plus 13, it is still the same thing written or rearranged. I'm not sure if that calculation makes sense to everyone, where I say when they say calculate the nth term, they are referring to an equation in the form of n, or a simplified equation of that arithmetic sequence in a form of n. Does it make sense, guys?
Yes, sir.
Yes, sir.
So remember, guys, this is just a warm-up. Starting from tomorrow going forward, we'll be trying to do some more complicated problems. So just make sure that you notice calculations involved. So let's maybe try to move on to the next question, which says calculate T30, the 30th term of the pattern. So they want you to calculate T30. This one is easy. Remember here you got your Tn to be, what was it? Was it 13 minus 5n? I think so. So here, can you see in position of n, they substituted 30. So that means where you see n, you substitute 30. That's what they want. Where you see n, you substitute 30. So you punch all of that on your calculator. What are you getting there? What is that times that?
Negative 137.
Negative 137. Is this what you're getting?
Yes,
Yes, sir.
Okay. So if we try to make sense of what honorable member said regarding the position, so that means if we continue by saying 8 plus negative 5 plus negative 5, that plus negative that, and when we get to a term number 30, when we get to term number 1, 2, 3, 4, 5, 6, 7, 8, and 30, when we get to term number 30, it is going to be that value there. So that means term number 30, it is actually equals to that. I hope that makes some sense. So now 3.1.4, they are saying which term of the pattern is equals to negative 492. Which term of the pattern is equals to negative 492. So in this case, they're actually asking which term is equals to that. Is it term 50? Is it 10 million? Is it 10,000? So you still use that same formula there, but you substitute differently. So when I said there's a strategy to work out these things, can you see where they substituted your n with a number? You know that's where you just substitute. But this one where they say which term of the pattern is equals to something, you know, they actually want you to calculate n itself. So in short, that means the whole of this, you are going to equate it to that, which means you are having negative 492, which is equals to 13 minus 5n. So when I say you'll be calculating for n itself, I was trying to think of another way of explaining it, which is it's more like they want to know the position of that value in that pattern. So in short, they just want you to calculate for n. How do you do that? Obviously, you transpose, then you're having negative that minus 13 is equals to negative 5n. What is that?
Negative 505.
What is this one only?
Negative 505.
500
5.
what did you say there?
Negative 505.
535. Is that what you said?
And 5. 505.
Umi, I wanted to say, remember not to click on a button which says share screen, or don't do a video from your side. If you do that, 505, negative 505. So obviously it's going to be equals to negative 5n. I wanted to say to Umi and everyone else, avoid clicking on a button which says share screen, and also don't do a video from your side. If you do it, for example, it's going to impact negatively on this recorded lesson. So instead of you guys seeing me doing that calculation, we are then going to see your screen if you shared it, or otherwise if you've done a video from your side, you will only hear me speaking, but we'll be seeing the face of whoever who has activated video on their side. So just make sure that you don't click on a button which says share screen, and also you don't share screen. Okay, so now obviously we are going to divide by that on both sides, so that that cancels that, and then n is equals to, what is that?
101.
101.
Yes, 101. So that means if we count and say term 1, term 2, term 3, term 4, term 5, term 6, term 7, when we get to term 101, the value of term 101 is going to, it's going to be this one. That's when you explain the calculation that you've just done. So I think that question, we can leave it there, and maybe tomorrow I will look for another question, and we will also include this last part of this question. But before I sign out, is there someone who's got a question, or are we now on the same page?
We're on the same page, sir.
Okay. I'm very much glad that you guys understood, but I just want to quickly explain something to you guys in terms of how we'll be having our test. So I'm going to create a new group where in that group I'm only going to post recorded videos, and also that's where we'll be writing tests in that group. So in that group, there's going to be a folder where you find recorded videos, meaning in that folder, I'm going to share the links of the recorded lessons. I won't be sharing them in this same group where I'm doing the lesson, just so that you don't miss the messages sent inside this group. Then you know that all the videos or recorded lessons for 2023, they are posted in this same folder. Then you just scroll down to find whichever lesson that you want, because I noticed if it's posted in this same group during that time of exams, or if you want to revise, or if you want to for you to navigate and find it. And then also under this same group, I'm then going to have a grade 10, a grade 11, and also grade 12. So all the grade 10s are going to be writing their tests that will be given them inside that group. 11s inside that, 12 inside that group. So what's going to happen is, let's say for example, if our test on Saturday is going to be at 8 o'clock, that means at 8 o'clock, everyone will need to log into their specific group, just like you did now to attend this lesson. Then exactly, for example, at 8 o'clock, but it won't be this late. I think maybe it could be around what, maybe 18 or 19. We'll just see at what time. So what's going to happen is that exactly at this time in each of this group, you won't write the same question paper. There's going to be one for 10, one for that, one for that. Then exactly that time, I'm going to post a question in each of these groups. And then after maybe every 10 minutes, after every 10 minutes, I'm going to tell you that maybe 20 minutes remaining, 10 minutes remaining, then it's time up. Then after time up, that's where you wrap up. By wrapping up, it means you take a photo of your workings and then you send it via inbox, not in the group, but via inbox. You'll be given, let's say, for example, 2 minutes just to submit. Then once you have submitted, that's it. Then it's up to us to work it out from there. So what we normally do, we actually go through your scripts to check where you got what wrong and everything. Then if there's a need for us to do corrections, then we're just going to be doing corrections. Otherwise, if it's a matter of pointing out where you got confused or whatever the case may be, we'll just see how to work it out. So just make sure that you do not miss these tests, because I won't be setting something coming from my head. I'm going to be taking questions from past exam papers so that you have the same feeling that you'll be having when you'll be writing your exams. So with you being honest and not copying and not asking help from your parents, it helps us to know where you are struggling. So whether you get 100%, whether you get 0, whether you get 50%, to us it doesn't really matter that much, because you are actually giving us a reflection of your understanding based on what we have covered. If you try to cheat, I'm telling you, you will be cheating yourself, because you get 100% and I think you fully understand, then we focus on something else. Come exam, you get 0. So it's better to fail our test, and then from there, we correct you until you get it right. Then we know that come exam, you won't make the mistakes that you made during these tests of ours. So the mistake that you guys make is to wait until exam time and start working the exam type of question papers. You don't do those during that time. You do those in the beginning of the year, so that you know how much time to spend on each question. You understand the level of difficulty for your specific grade. So that's how, in short, it's going to work. So just in case, if you attended today's lesson and you are ready for the test, I think I've sent an inbox to most of you guys greeting you or whatever. So in that same inbox, you can just respond anytime after this lesson and just say ready, so that I will give you a link to this group so that you are there. And then come Saturday, you know you are already in the group, and also you can straight away access the links to those to catch up and prepare for that. But if you keep quiet, it also becomes a bit challenging in case your parent ask and say, how is my child doing? We are not able to tell whether you are improving or not. And also, if you write and you fail, I am therefore able to notice that, okay, there's this specific learner who needs maybe some extra attention. Then I'm able to look at your script and notice where you are struggling. Then on my next lesson, I'm going to prepare specifically to address those challenges that you'll be having. So when we get to exam times, I will know what not to talk about much and what to talk about much. So not compulsory, but advisable that, and again, everyone is encouraged to participate in all our tests. it won't only be our maths test, but you'll also be writing tests for other subjects. So it will, for example, be question 1 of a 2013 exam paper, because that's what we have covered up to this point. Now that we have started with sequence and series, the next test, it will just be question 2 of whatever past exam paper. And then when we move on to function, the same thing. Then during that time of holidays, as we don't close, we are only going to close end of the year. So that means during those holidays, that's when you write a full question paper in preparation for June exams. We do the same in term 3 and 4 in preparation for final examinations. I'm telling you guys, if you can make sure to participate in all of those, all grade 11 will get distinctions in 2014, depending on how much you invest your time in your studies. You who is in grade 12, there is a chance that you can still get above 80%, which is a distinction. So just make sure that you balance your subjects. Don't focus only on maths, but also focus on other subjects so that you balance. Guys, did that make sense to everyone, where you say you know what to do after this lesson, which is sending an inbox saying ready? Then I'll give you a link and then you just join. Did you all get that?
Yes, sir.
No, sir.
Okay, with that no, let me say I will send the link in the group and say join. So just make sure to join. So guys, as always, my name is Desmond. Thanks for joining, and I'm out.